Alright, this video is on calculating surface area. So, we've done surface area probably in previous years before, but reminder, the definition: surface area is the sum, so that's adding up all of the areas of all of the faces of an object. So, for example, if we had a cube, right, we would find the area of this face and the back one and the side one and the top and the bottom, find the area of all of them and add them all up, and that would be the surface area of the rectangular prism, or in this case perhaps a cube. Now you notice that if this was an exact cube, that means it's 6 squares put together. Each of the sides are a perfect square. We could use what we've learned about symmetry, or see the symmetry in it, and be able to determine the area of just one of these sides. And if we know that all of the 6 other sides are the same, we could just, instead of calculating each of them, we would be able to instead just multiply by 6. So be looking for that as we go through these, to see if there are any sides that we can determine are the same because of symmetry. So we'll do an example here. This example is out of your textbook. We'll do it together here. Okay, so you want to waterproof a tent. You need to determine the surface area of the tent sides and ends to purchase the right amount of waterproofing spray. You do not have to waterproof the bottom, that's already done. Calculate the surface area, and we're going to give our answer to the nearest tenth of a square meter. So we'll draw out a tent here. Basically it's going to look like a triangular prism. Okay. So we're going to put some dimensions on here. This length of the tent, we'll put the door of the tent is up here on the front. Right. We're going to say that this length is 2 meters. The depth of the tent is going to be 3 meters, and the height, okay, so the height of the tent would be 2 meters as well. Okay, so we've got a few sides to deal with. We have the triangle side here, and by symmetry we're going to say that that is going to be the exact same as the same surface area as the triangle in the back. Okay. Then we also have this rectangle right here, and by symmetry we're going to say that that is the same as the rectangle on the other side. We don't need to worry about the bottom of it, so therefore we only need to find the areas of both the triangle and the rectangle. We'll multiply each of them by 2, add that together, and that should give us the overall surface area. Okay, so we will start with the easy one. We'll find the surface area of the rectangle. Okay, so if we remember our formulas for surface area of a rectangle, we have a length times width. Okay, so if we look here, the length of the surface area, we could say, is this distance right here. Okay, it's 3 meters. Okay, and the width is going to be this dimension right there. Do we have that one? No, we haven't been given that one, so we're going to need to do a little bit of work to find that. Okay, and we're going to use a different color for that. Okay, to find that length, we can look at this triangle that forms right here, and we're going to see that that's a right triangle, and with a right triangle we will be trying to find this dimension there is the hypotenuse. So we can use our formula: a squared plus b squared equals c squared. This is Pythagorean's theorem from previous years. So if we look at a squared, we'll say this is a there and this is b there. A squared, we can see, is half of the total bottom of the tent. Right? half of 2 is 1, so we'll have 1 squared. And we're going to be adding that to our b squared. B is the height of the tent. We said that the height of the tent is this length right here, 2 meters. 2 squared. And that's going to equal our c squared. So 1 squared is 1, plus 2 squared is 4, c squared. So therefore, so c squared is equal to 1 plus 4 is 5. Take the square root of both, and c would be equal to the square root of 5. And if you punch in on a calculator, you'll be able to see that if you want to put that in a decimal form, the square root of 5 is about 2.24. About 2.24, and that's going to be in meters. Okay, so let's go back to where we were now. We were looking for the surface area of the rectangle. Okay, we now have that length C, right? The width of our rectangle, okay, is 2.24 meters. 2.24 meters. Okay, so when we multiply that together, 3 times 2.4 works out to 3 times 2.4 works out to 7.2 meters. That would be the surface area of one of the rectangles. And remember, in total, we have 2 rectangles, so 2 of those would be 14.4. Sorry, I made an error there. That's meters squared. And so our total is 14.4 meters squared. Now that is the rectangle part of it. We need to also determine the area of the 2 triangles. So we will choose a different color for that and find the surface area of one of the triangles first. Remember that that is base times height divided by 2. Okay, our base is given to us in the problem here. Base is 2 meters times the height is also given here. The height is also 2, and we're going to divide by 2. So 2 times 2 is 4, divided by 2 is 2 meters squared. And again, we have 2 of those triangles, front and the back, so the total would be from the triangles is 4 meters squared. And so all together our surface area that we have is that we would need to waterproof would be the 14.4 meters squared plus the 4 meters squared to the nearest tenth works out to 18.4 meters squared. Okay, hope that makes sense. Okay, we will quickly go through this page as well. Different formulas can be used to find the surface area of a rectangular prism or a cylinder. But there's one formula that works for both. This is the general formula. And of course, it's specific to each one. So if we had a rectangular prism, okay, we could determine what the base is. So a rectangular prism actually could be a fair amount of, or you could choose any of them as the base, but say we choose the bottom as the base. The bottom is going to have a length and a width, okay, and so if we determine what the surface area of that area of the base, we're going to go 2 times the area of the base is length times width. We're going to add that to the perimeter of the base times the height. And so the perimeter is 2L plus 2W times height. Okay? We could work that all out to come up with a nice fancy formula here. 2L 2LW plus 2LH plus 2WH. Okay? And we can see that there is a you could factor it all the way out, and this is maybe going a little bit beyond us. You could come up with a nice complicated, or maybe a little more simple actually, formula, a general formula for surface area. Okay, or alternatively you can do the method that we did before, where we just add up all of the methods. Okay, it works out a little bit more clearly maybe with the surface area of a cylinder. So a cylinder has a circular base. Okay, so basically a circular base means the area of the base is, remember the area of a circle is 2 times pi r squared, and the area of a circle is pi r squared, plus the perimeter of the base. Perimeter of a circle is also known as the circumference. Circumference is 2 pi r, okay, and multiplied by the h. And so this is a nice formula for the surface area of a cylinder that you can remember is 2 pi r squared plus 2 pi r h, or if you wanted to simplify it or factor it, you could say 2 pi r times r plus h, and that's a nice formula that you can use. Okay, so that is our lesson for today. We will have a chance in class to do some practice questions using these formulas and just adding up all of the surface areas. So, hope that was helpful.